Good morning to all. Welcome to Sigma e-learning Smart Way to Excellence. The topic we will discuss today is circles. In our real life, so many times we have observed about the circles. What is common all in these figures? The similarity is they are circular in the shape. Concept circles is very much important in mathematics as well as in physics also. Who are watching my classes for the first time, please subscribe my channel. If you like it, please comment and share to your friends. Mathematically, circle is a two-dimensional figure in which all points on circle are equidistant from the center. Circle is a two-dimensional figure in which all points on the circle equidistant from the center. For example, just imagine it as a circle. This is the center of the circle. Imagine some points. This is one point, this is one point, this is one point. Just imagine all the points on the circle which are equally distant from the center of the circle. For example, this is the one point. This is 3 meters away from the center. Let us imagine one more point here. This is also 3 meters from the center. Let us imagine one more point on the circle. This is also 3 meters from the surface. The same thing explained in this point number 1. The circle is a two-dimensional figure in which all points on the circle are equidistant from the center. In this slide, we will discuss the relation between the circle and a line. Let us suppose PQ is the line which is passing away from the circle. We can call it as a non-intersecting line. Why? Because the line PQ is passing away from the circle or out of the circle. So we can call it as non-intersecting. Why? Because the line PQ and the circle not interacting with each other. So I can call it as a non-intersecting. Then come to the figure number 2. This line PQ cutting the circle at point A as well as at point B. So this kind of phenomena, I can call it as a secant. What is secant simply means the line PQ passing through the circle by cutting the circle at 2 points, at point B, at point A. So this kind of representation, I can call it as a secant. Then coming to the tangent. Carefully observe the third figure. Line PQ not going through the circle as well as it's not out of the circle. So this is not going through the circle as well as it's not away from the circle. It just slightly touching the circle. So I can call this kind of line as a tangent. So any line which is away from the circle, I can call it as a non-intersecting line. If any line passing through the circle at 2 different points, I can call it as a secant. Figure 1, I can call it as a non-intersecting. Figure 2, I can call it as a secant. Figure 3, I can call it as a tangent. Parts of circle. So first of all, what is radius? What is the radius? Radius is simply the distance between the center of the circle and the point on the circle. Let us imagine this is a point on the circle. The distance from this point to the center of the circle, I can call it as a radius. See here in this figure, I have explained that. What is radius? The distance between the center of the circle to point on the circle, I can call it as a radius. What is the diameter? Diameter is the distance between two opposite points which are located on the circle. The distance between two opposite points which are located on the circle also passing through the radius. Then only I can call it as a diameter. In this figure, I can call this green dotted line as a diameter. Why? Because this line, this diameter line connecting two opposite points. See, this is one point, this is one point. It connecting two opposite points, which is also passing through the radius. Why? Because this half distance I can call it as a radius. So these opposite lines which are located on the circle passing through the radius, the distance between these 2 points, I can call it as a diameter. The half distance is radius. The full distance, I can call it as a diameter. So the diameter equal to 2 times of the radius. What is chord? Simply, the chord is a line which connect 2 points which are located on the circle. See, let us imagine this is the point on circle. This is also point on the circle. I am connecting 2 lines. So this line became the chord. There is a difference between the chord and diameter. Simple. The difference between the chord and diameter is, in case of diameter, this line passed through the radius. But in the case of chord, this line not passed through the radius. So this is the difference between the chord and the radius. If a line passed through the radius, I can call it as a diameter. If the line not passing through the radius, I can call it as a chord. See, observe the similarity between the chord and the secant. The extension of chord, I can call it as a secant. See here, this is one point, this is one point. So these two connecting points, I can call it as a chord. If I extend these points, so see here, I'm extending this line to here, I'm extending this line to here. Now it will become the secant. If I can't extend this line, it will become the chord. See here, here I am not extending this line, so it will become the chord. But in this figure, I am extending the line, so it will become the secant. This is the difference between the chord and secant. What is circumference? Simply, the circumference is the total length of the circle. For example, see here, this is the circle I am imagining. The total length of the circle, I can call it as a circumference. If the entire round of the circle, if I measured as 20 centimeters, then circumference is the 20 centimeters. If the entire length of the circle is 40 centimeters, then I can conclude the circumference is the 40 centimeters. What is the arc? Arc is a simply curved figure which is located on the circle. Okay, see, this is not the straight line. See, observe this blue line. This is not the straight line, but it is a curve which is also located on the circle. So I can call it as an arc. Sector. What is sector? Sector is a two-dimensional which has area. For example, the triangle area, not the exactly triangle, just imagine it as a triangle. This entire triangular area, I can call it as a sector. Then coming to the segment. What is segment? Segment also a area type of property of circle. This complete blue zone is a segment. This means the area which is enclosed within these lines, I can call it as a segment. The area enclosed within this red zone, I can call it as a sector. The sector and segment they are not simply lines, they are areas. Means they have a little bit of area, but remaining all are simply the lines. Just imagine the arc is a simply line, the chord is a simply line, radius is a simply line, the diameter is a simply line, secant also a simply line, the tangent also a simply line. But in coming to the segment and sector, they are not simply the lines, they are areas. So this is the difference between the segment and sector and other parts of the circle. See, the secant is the extension of chord outside of the circle. See here, the secant is the extension of the chord which is outside of the circle. What is tangent? The tangent is any line that intersects the circle at only one point. For example, just imagine it as a circle. The line, for example, this is the line. It intersecting it touching the circle at this point, at only this point. So the line which is intersecting at circle at only one point, that kind of line I can call it as a tangent. For example, consider this line touching this circle at this one point only. So I can call it as a tangent. Consider another line, this line also touching this circle at particular points. So I can call it as a tangent. In this manner, there is an infinity number of tangents at infinity number of points on the circle. There are some most important points to be remembered regarding the tangents. The point number one is, there is one and only tangents at any point on the circle. For example, at this point, we can observe one and only tangents. I cannot observe more than one tangent at particular point. At this point, I can have only one and only tangents. I can't get more than one tangents at particular points. So this is the point number one. Then come to the point number two. The tangent to a circle is special case of the secant when two endpoints of its corresponding chords are coincides. Theorem 10.1. The tangent at any point of circle is perpendicular to the radius through the point of contact. The theorem 10.1 saying that any tangent is perpendicular to the radius of the circle. See here, this is the tangent, this is the radius of the circle. These two lines are perpendicular to each other. Okay, again consider this is the one tangent, this is the radius. So these two lines are perpendicular to each other. Okay, again this is the this is one tangent, this is the radius. So this is also perpendicular to the radius. Again consider this is one tangent. This is the radius of the circle. This is also perpendicular to this tangent. So the same thing explained in theorem 10.1. Now some more points to be remembered here according to theorem number 1. All the tangents perpendicular to the radius of the circle. See, this tangent also perpendicular to the radius. 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 The same thing I am explained in the point number 1. All the tangents perpendicular to the radius of the circle. Okay. The point number 2. The line containing the radius through the point of contact is also sometimes called as normal. Okay. For example, this is the line. This is the tangent. So this line passing through the radius. So I can call it as a normal. Means the line R is normal to the line tangent. The same thing. The line containing the radius through the point of contact is also sometimes called as a normal to the circle at a point. Come to the point number 3. There is no tangent to the circle passing through a point lying inside the circle. It means that if any line passing through the inside the circle, we cannot call it as a tangent. For example, this line passing through the circle but within the circle, so I cannot call it as a tangent. It's the same thing I am explained here. Point number 4, we cannot draw more than one tangent from the point on the circle. We have already seen this. From these points, I can make one tangent only. I cannot make more than one tangents by passing through this point. What is point number 5? There are exactly two tangents to the circle through a point lying outside the circle. For example, let us imagine the circle. This is the circle. This is the point lying outside the circle. By projecting two tangents from this point, it will become the one tangent. It will become the t tangent. Second tangent. In the point number 5 saying that by the external points, we can able to make only two tangents to the circles. By the external point, we can able to make only two tangents. This is the one tangent. This is the second tangent. This is the only possibility to make tangents from the external point. So this is the thing explained in point number 5. And also PQ and PR is called the length of the tangent. See, the length between PQ is called length of the tangent 1. The length between P and R, I can call it as the length of the tangent 2. 10.2. The lengths of tangents drawn from an external point to the circle are equal. The same thing I had explained in the previous figure also. So the tangent which is drawn from the external point, this is the PQ. One tangent drawn from the external point P. This is the another tangent drawn from the external point P. So this is one tangent. This is another tangent. These two tangents always equal. So the length of PQ is always the length of PR according to the theorem number 2. So the PQ equal to PR. Also the length of CQ equal to the length of CR. Why? Because simply the CQ is the distance between the center of the circle to point on the circle. So I can call it as a radius. So this is one radius. This is the another radius. So these two radius are same. So I can call it as CQ equal to CR. Not only this, we have three more conclusions can be drawn from the given figure. The angle 1 equal to angle 2, angle 3 equal to angle 4, angle Q equal to angle R. For example, observe this dotted line. This dotted line drawn from the external point to center of the circle. This is the straight line drawn between the external point to center of the circle. Okay, so this is the dotted line. Angle 1 as the angle between PQ and this dotted line, I can call it as a angle 1. The angle between this straight line and the PR, I can call it as the angle 2. Okay, the angle between CQ and the straight line, I can call it as a angle 3. The angle between PC and CR, I can call it as a angle 4. In this kind of situation, the angle 1 means the angle of this equal to the angle of this. The angle of 3 equal to the angle of 4. The angle of Q means the angle which is at here. The angle of Q equal to the angle of R. So these are three major conclusions can be drawn from the theorem number 10.2. The triangle PQC, the triangle PRC are similar in the nature. The triangle PQC, the triangle PRC are similar with each other. If anyone confused about the similarity of triangles, please go through the chapter which is already explained. According to similarity of triangles, the corresponding angles are proportional. What are the corresponding angles here? PQ is the corresponding angle of PR. So PQ by PR equal to QC by CR. In two concentric circle, the chord of the larger circle which touches the smaller circle is bisect at the point of contact. Simply means the concentric circle means the smaller circle which is lying inside the larger circle exactly at middle. For example, let us imagine a circle C1. So this is the larger circle. I will draw a chord. See, I'll draw a chord AB to the larger circle. Also, this chord became tangent to the smaller circle. In this kind of situation, this chord of the larger circle perpendicular to the radius of the smaller circle. The same thing explained in point number 4. Listen carefully. The C1 is the larger circle. If I draw a chord AB to the larger circle, also this chord became tangent to the smaller circle. In this kind of situation, this chord is perpendicular to the radius of the smaller circle. The same thing has been explained here. Also, AP equal to BP means line OP cutting the AB into two equal parts. If the AB equal to 10 centimeters, this OP will cut as 5 centimeter and 5 centimeter. If the AB equal to 20 centimeters, then OP will cut at as a 10 centimeters and 10 centimeter. In this manner, the OP perpendicular to the AB. See point number 5. If two tangents TP and TQ are drawn to a circle with center O from an external point T, then the angle PTQ equal to 2 times of angle OPQ. I'll explain now. If two tangents drawn from point T which is external, two tangents TP and TQ are two tangents which are drawn from the external point T. So T is the external point. I can draw one tangent TP, one tangent TQ. Okay. The center of the circle is the O. Okay. In this kind of situation, angle PTQ, see here, angle PTQ equal to 2 times the angle of POQ. Means, see here, observe the middle term. Angle PTQ equal to 2 times the angle OPQ. So, PTQ is the one triangle. PTQ. This is the one triangle. OPQ is the another triangle. OPQ is the another triangles. The angle at T equal to 2 times the angle at P means the angle between TP and TQ, which is this. So, this angle is 2 times the angle between PQ and PO, means this angle. Angle between two tangents is 2 times the angle between this line and this line. So, angle at T equal to 2 times the angle at P. So, angle at T equal to 2 times the angle at P. And note here, you must be strong in triangles to solve the problems of circles. To solve the problems on circles very easily, we have to be stronger enough to solve the problems on triangles also. So, if anyone not able to understand the concepts and problems in the circles, please go through the triangles chapter. Example, if the angle between two tangents drawn from the external point P to the circle of radius A and center O is 60 degrees, find the angle between OP and tangent 1. So, from the given data, I have to make the rough figure. This is the external point P. This is the circle I made. This is the one tangent. This is the another tangent. From the given figure, the angle between two tangents is 60 degrees. See here, the angle between this tangent is 60 degrees. Okay, the radius is A from the given data. So this is the radius, so I can make it as A. According to theorem number 10.2, angle 1 equal to angle 2, angle 3 equal to angle 4. Means angle 1 and angle 2 bisect the angle between these two tangents. Angle 1, angle 2, dividing the angle between two tangents into two equal parts. So angle 1 and angle 2 bisecting the angle between two tangents. So angle 1 and angle 2 equal to 60 degrees, as well as from the theorem, the angle 1 and angle 2 bisect the angle between two tangents equally. So the angle 1 became 30 degrees, also angle 2 became the 30 degrees. If this video is informative, please share and subscribe.